The earth has the capacity to supply everything that man needs to survive. We breathe in air, drink water, use wood for furniture. The list of materials that we obtain from the earth is endless. The abundant materials that the earth provides us with are compounds of elements. An element is the simplest form of matter, in that it cannot be further broken down using any chemical means. Elements can be mainly classified into three types: metals, metalloids, and non-metals. Elements like sodium, iron, magnesium, etc. are metals. Metalloids are elements that possess properties of both metals and non-metals. Elements like silicon, germanium, antimony, etc. are metalloids. Elements like nitrogen, chlorine, iodine, etc. are non-metals. Physical properties of metals. Physical state. Metals are solids at room temperature, with exception of mercury and gallium, which are in liquid form at room temperature. Luster. Metals are shiny in their pure state and give highly reflective surface on polishing. Malleability. This is the property possessed by metals, turning them into sheets on hammering. Ductility. This is the ability of metals to be drawn into thin wires. Gold and silver are the most ductile metals. Conduction of heat. Metals are good conductors of heat, with silver and copper being the best conductors. Mercury is a poor conductor of heat. Conduction of electricity. Metals are good conductors of electricity. So, they are used in making electric wires. Hardness. Metals in general are hard, with degree of hardness varying from metal to metal. Metals like sodium and potassium are soft metals, getting easily cut with a knife. Melting point and boiling point. Metals have high melting and boiling points usually. Tungsten has highest melting point, and sodium and potassium have low melting points. Sonorous. Metals are sonorous, that is, they produce a sound on striking on a hard surface. Physical properties of non-metals. Non-metals exist either in solid or gaseous state, with the exception of bromine that exists in liquid state. Non-metals usually do not have luster. Iodine is the only non-metal that has luster. Non-metals do not possess the property of hardness, except carbon in the form of diamond. Diamond form of carbon is the hardest substance known. It also has a high boiling and melting point. Non-metals are non-conductors of electricity with the exception of graphite, another allotrope of carbon. Chemical properties of metals. Reaction of metals with oxygen. If we put the metals in order of their reactivity, from most reactive down to least reactive, we get a list called the reactivity series. Going from bottom to top, the reactivity of metals increase. With the exception of noble metals like gold, all the metals react with oxygen to form metal oxide, with the difference in reaction conditions corresponding to their reactivity. Sodium and potassium are at the top of reactivity series. Sodium reacts with oxygen to form sodium oxide at room temperature. Hence, sodium is stored under kerosene oil to prevent with oxygen. Potassium reacts with oxygen to form potassium oxide. Most metallic oxides do not dissolve in water, but sodium and potassium oxides dissolve in water to give alkalis and are basic in nature. Reaction of magnesium with oxygen. Magnesium does not react with oxygen at room temperature. It reacts with oxygen on heating and burns with intense light and heat, forming magnesium oxide. Like magnesium, zinc does not react with oxygen at room temperature. It reacts with oxygen on strong heating, forming zinc oxide. Iron reacts with air vigorously only when iron filling are sprinkled in the flame of the burner. Reaction of copper with oxygen. Copper does not burn, but on heating, the hot metal is coated with a black layer of copper oxide. Reaction of aluminium with oxygen. On strong heating, aluminium gets coated with a layer of aluminium oxide. Thus, we can see that the reactivity of metals decreases from potassium to copper. Metal oxides. Metal oxides are usually basic in nature, but some metal oxides like aluminium oxide and zinc oxide react with acids as well as bases, producing salt and water. Hence, they are known as amphoteric oxides. Reaction of metals with water. Some metals react with water, but they react in different ways depending upon their reactivity, like their reaction with oxygen. Metals placed low in the activity series, such as gold, silver and copper do not react with water at all. Reaction of potassium and sodium with water. Potassium and sodium react vigorously with water to liberate hydrogen gas and alkaline potassium hydroxide and sodium hydroxide respectively. This is an exothermic reaction. Hydrogen gas released during the burning process reacts strongly with oxygen in the air. Reaction of calcium and magnesium with water. Calcium and magnesium react less vigorously with water than potassium and sodium. Calcium and magnesium both start floating when reacted with water, as bubbles of hydrogen gas stick to the metal surface. Not enough heat is evolved to induce burning of the released hydrogen gas. Reaction of aluminium, iron, and zinc with water. Metals like aluminium, iron, and zinc react neither with cold nor hot water, but only with steam, forming metal oxide and hydrogen gas. Reaction of metals with acids. Metals react with acids to give salt and hydrogen gas. The reactivity decreases in the following order. Reactivity of aluminium is less than that of magnesium. Reactivity of zinc is less than aluminium, and iron has least reactivity. Reaction of metals with hydrochloric acid. Metals react with dilute hydrochloric acid to form metal chloride and hydrogen gas. Magnesium reacts with dilute hydrochloric acid to form magnesium chloride and liberate hydrogen gas. Aluminium reacts with dilute hydrochloric acid to form aluminium chloride and liberate hydrogen gas. Copper does not react with dilute hydrochloric acid. Reaction of metals with sulfuric acid. Metals react with sulfuric acid to form corresponding sulfates and hydrogen gas. Iron reacts with sulfuric acid, forming iron sulfate and hydrogen gas. Reaction of metals with nitric acid. Nitric acid is a strong oxidizing agent. So, when a metal reacts with nitric acid, hydrogen gas is not evolved, since it oxidizes the evolved hydrogen to water, and itself gets reduced to nitrogen oxide. Copper is oxidized by concentrated nitric acid to form copper nitrate, and itself is reduced to nitrogen dioxide. Magnesium and manganese react with dilute nitric acid to evolve hydrogen gas. Aqua regia. Aqua regia is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. It can dissolve noble metals like gold and platinum. Reaction of metals with solutions of other metal salts. More reactive metals displace less reactive metals from their salt solutions, showing displacement reaction. When an iron nail is put in a solution of copper sulfate, the iron nail gets coated with reddish-brown copper, and the blue color of copper sulfate solution fades away. Iron is more reactive than copper and displaces it from copper sulfate solution. Reaction of metals with non-metals. The nature of reactivity of elements depends on their electronic configuration. Noble gases have completely filled valence shell, hence are chemically inactive. The table shows the electronic configuration of some metals and non-metals. Sodium and chlorine are two dangerous substances. Reaction of sodium with water is explosive. Chlorine is a poisonous gas that was used as a weapon during World War I. But these two dangerous substances react together to give sodium chloride, that is, common table salt, an edible substance of daily use. Formation of sodium chloride. All elements react in order to get a stable electronic configuration, that is, 8 electrons, octet, in their outermost shell. Atomic number of sodium is 11, that is, 11 protons in the nucleus and 11 electrons in the surrounding shells, K, L, M. Therefore, its electronic configuration is 2, 8, 1. Sodium can thus acquire stable configuration of 2, 8 by giving away 1 electron. Atomic number of chlorine is 17, that is, 17 protons in the nucleus and 17 electrons in the surrounding shells, K, L, M. Therefore, its electronic configuration is 2, 8, 7. Chlorine can thus acquire stable configuration of 2, 8, 8 by accepting 1 electron from sodium. Sodium acquires 1 unit of positive charge because of 11 protons, but only 10, 2, 8 electrons, forming sodium cation, Na+. Chlorine acquires 1 unit of negative charge after accepting an electron because of only 17 protons but 18 288 electrons, forming chloride anion Cl-. Sodium and chloride ions, being oppositely charged, are bonded by strong electrostatic forces of attraction, resulting in the formation of sodium chloride NaCl through ionic bond. Ionic or electrovalent bonds are formed by give and take, that is, transfer of electrons, and the resulting compounds are known as electrovalent or ionic compounds. The compounds which are formed by mutual sharing of pair or pairs of electrons between two combining atoms are known as covalent compounds. For example, water, ammonia, etc. Properties of ionic compounds. Due to strong electrostatic force of attraction between positive cation and negative ions, anion, ionic compounds are hard solids. Ionic compounds are brittle in nature and break into pieces on application of pressure. Due to strong ionic force of attraction, electrovalent compounds have high melting and boiling points. That is, more energy is required to separate the molecules while converting them into liquid and gaseous state. These compounds are soluble in water and other polar solvents, but insoluble in non-polar solvents like kerosene, petrol, etc. Due to strong ionic forces of attraction, electrovalent compounds are rigid in solid state, hence do not conduct electricity, but in molten state, the ions move towards opposite electrodes when electricity is passed through them. Occurrence of metals. Only the most unreactive metals, example gold, silver, and platinum, are generally found in free or native state. Most metals occur in the form of their oxide ores, carbonate ores, or sulfide ores, etc. Minerals are the naturally occurring compounds of metals. Ores are those minerals from which metals can be profitably extracted. The impurities like soil, sand, rocky material, etc., which are present in ores along with metal compounds, are known as gangue. Extraction of metals of low reactivity. Metals at the bottom of activity series such as copper, mercury, silver, and gold are the least reactive. Some of them are found in free state, example gold, silver, and copper. Copper and silver are also found in combined state as oxide or sulfide ores. Being less reactive, these metals can be easily oxidized and then reduced to metallic form. For example, copper sulfide is oxidized to copper oxide, which is then reduced by copper sulfide to metallic copper. Similarly, when cinnabar, that is HGS, an ore of mercury, is heated in air, it is first converted to mercuric oxide, which on further heating is reduced to mercury. Refining of metals. The metals extracted from their ores are not very pure, that is, they contain impurities. Most widely applicable method for refining impure metals is electrolytic refining.